sometimes this is going to give you a higher budget, sometimes it's less. In particular instances, though, it also gives you some other options. Fixtures, which is a pretty wide definition, but you can get an additional 1 watt per square foot if you've got decorative fixtures in it. And also, if you've got a retail, so if you have a retail building, it's going to give you some extra credit. So it's more advantageous, I would say, in those particular instances to go with the space-by-space method.
You're also, with this approach, probably the biggest thing is, here's, and you go, well, okay, this room is a storage area. This, etc. And you multiply it by the much more significant in this section. You can tables if you get the code, but in the end, the best part of that, if you use ComCheck, the tables are built in, and it does the math for you. So you're going to see why we were pushing hard to use ComCheck for this. So, it just, for example, it says, if your building has an audience seating area, and it's a, well, I don't know. You can just see there's different watts per square footage. If you have a classroom or a training room, you're allowed 1.4 watts per square foot. Unless you're in jail, you get less wattage. That's how that works. So I don't know who came up with these or why, but there you have it. The other big advantage of space by space is that you might actually, besides have a bigger number, you can get sort of what they call additional lighting power allowances. You get sort of bonus wattage, if you will. You get bonus additional watts because you went to the extra effort. And this is a big one. Decorative luminaires, a lot.
And it's sort of interesting, we were having this discussion last time. Actually, Lutron was our lunch sponsor, so they were there and had a lot of good things to say about lighting, obviously. But what is considered a decorative luminaire? The definition is pretty squishy, but it's really anything that's not for task lighting. So if you've got a sconce washing the wall, that would actually be applicable. So that's saying, hey, in that space where that's used, you can actually add an additional watt per square foot, which is fairly significant. And then retail lighting. So if you've got a retail space, you can say, hey, on top of, just off the bat, you get 1,000 extra watts. Bam, we're going to give that to you. And then depending on the type of retail that you have, you're going to be able to multiply times different wattage. So retail 1 is everything not covered under these other ones. Retail 2, vehicles, sporting goods, small electronics. If you have that retail area square footage, you can multiply that times 1.7 watts per square foot. Furniture, clothing, cosmetics, artwork, 2.6. You get down to jewelry, crystal, china, 4.2 watts per square foot. So I think retail application, if you really feel like you need to light up your retail goods, you really want to probably go through the space-by-space method. Does that make sense? Everybody following?
You can, you can sort of tell who's represented well in here. Retail gets all the wattage they could ever want, basically. And so that takes care of our budget. So I'm going to put a check mark by that one, Brandon. The next thing we're going to talk about is your actual installed design. Okay, this is what, in essence, you have to make sure comes in below your budget. Okay? So the light fixtures that count, they are, after you figure out your budget, the light fixtures that count have to add up to be less than your budget. And this term comes up that you may have heard before, the term efficacy. It's not efficient, it's efficacy. Efficacy is like a miles per gallon kind of thing. But with lights, it's what do you want out of the light? You want lumens, or light level, divided by the energy that you put in, which is watts. So sort of the miles per gallon. And just as an example, incandescent bulbs like these over your head, they have an efficacy of around 10. You get about 10 units of lumens out per watt. That's pretty bad. Fluorescent fixtures, you can get fluorescent fixtures that are basically over 100 lumens per watt. So a factor of 10 times greater than an incandescent bulb. So the code does not ever say you have to install, this, you can only install fluorescents. It doesn't say that. It basically is pushing you down on your budget to where you're pretty much going to, the idea that you could do this kind of thing in a commercial building today with all these incandescents, there's no way. You'd chew through your budget in no time. So
Code is definitely keeping up with
Yeah.
technological advances being made in the lighting industry, which I'd say probably of all the major sections we're talking about, HVAC, envelope, and lighting is definitely really on the cutting edge of becoming much more energy efficient.
Okay, so first of all, they're pushing us towards higher efficacy lighting, but they're not mandating it. You can use the wattage in your budget however you want to, as long as you don't exceed your budget. And there are certain lights that are just flat out not covered by the code. They're exempt from the code. They do not count against your budget, I guess I should say.
Yeah.
And for the ones that do not account against you in your design, they tend to be more process related. Some cases, they also later on are going to tell you, if you're going to exempt this, you also have to have a separate switch for it.
Yeah.
And sometimes they're life safety, like an exit sign. But most of these are kind of lights that are built into something, like refrigerator cases, or lights that are very process-based. Like, someone is doing a root canal over here on John. I would like them to have all the light that they need. Okay, John, that's the good news. We're going to let them have all the light they need for your root canal. And here's another example. Lighting for food warming. It's process lighting. That's exempt from the code. Casino gaming areas. Maybe that's what this is. This is a gaming area.
Yeah, it's the casino. You're right.
It says a casino right on the sign. I was very confused by that, but it's a gaming area. They must have had a good lobby, I think. I don't know. The last line on here. So these are all fixtures that do not count against your design. But the last line on here, we always remind people that, hey, whether it counts in your budget or not, you're still paying for it. So it would behoove you to think, for example, about display lighting and make sure that's efficient. You're still paying for it. So don't miss the opportunity just because the code exempts it. Okay. How do you calculate things in your design? This is called the rules. Brandon, you want to take us through the rules?
Them's the rules. So how do you calculate your wattage? So if we're talking about standard incandescent bulbs, it is not the actual rating of the bulb. So if you've got a 50-watt bulb, you're not using 50 watts. It's whatever the fixture it's in, what it's rated. So on that fixture, it's going to have a label, and it's going to tell you how many watts, what's the maximum wattage you can use. So if that's 100 watts, even though you've got a 50-watt bulb in there, you have to use 100 watts. If you have a luminaire with a ballast, it is the combination, the wattage combination of that lamp and ballast. And in line voltage track, it doesn't matter how many heads you have on that track, it's going to be always 30 watts per foot. So I could have a 10-foot track with 10 lights or 2 lights. The answer is still going to be the same. It's going to be 30 watts per lineal foot. Low voltage tracks, the transformer wattage, and anything else, it's really just what's specified.
So we're going to work a couple little examples to kind of reinforce this. So here's a scenario where we've got 8 fluorescent fixtures, 6 down lights, and 16 feet of track lighting. And so we're going to kind of start off, the 8 fixtures that are fluorescent, you've got 3 bulb fixtures. The old classic, I say old classic, I remember when this was the greatest thing ever. But the fairly common fluorescent light fixture that has 3 bulbs in it, right? And they're the T8 bulbs. T8 bulbs are 1 inch in diameter, 8/8 of an inch of diameter. A T12 is 12/8 of an inch. So the big fat 1.5 inch bulbs. Those are pretty much, for the most part, gone, at least in new fixtures. You've got 3 of these, and each of those bulbs, if you read what's on the bulb, it says this is a 32-watt bulb. You say, okay, 32-watt bulb, and there's 3 of them. That's 96 watts. But this thing is being driven by an electronic ballast, so it's actually only pulling 90 watts. The wrong way to do this would be to say, okay, 8 times 3 times 32 watts per lamp. That would, in essence, you're saying that counts as 768 watts. That's the wrong way, right? Is correct? Because the correct way to do this would be, how many watts does that fixture actually draw when it's operating? And the answer is 90. So it would be 90 times 90 times 8, which is 720. Does everybody see how we did that? So I know this is terribly exciting. I'm just trying to kind of work an example to sort of say the right way and the wrong way to plug it all in. And CommCheck will help you with some of this as well. All right. All right. Brandon, here's some downlights.
Yeah, so we've got 6 incandescent downlights. So those bulbs are specified as 60 watt, but they're put into a fixture that's 75 watts. So if we multiplied 6 times 60, that gets us 360, but this is not the right way to do it. Remember, we have to do it based upon the fixture rating. So it's 6 times 75. It's a pretty significant difference. And this is just a small calculation, but if you spread that out across an entire building, you could have some fairly large errors.
So once again, if for example, if the light fixture's over your head, if these fixtures are rated for a 150 watt bulb, but that's only a 100 watt bulb, then it still counts as 150 watts in your design. Does that make sense?
Yes, sir, Ken.
I mean, the incandescent bulb is supposed to be phased out in the next 2 or 3 years? 2 years?
It's coming. I don't know. I wouldn't hold my breath on it.
I think it depends on the wattage and stuff like that. So higher wattage are going to be phased out sooner, but who knows?
I mean, I thought by 2014 they would not be making any more incandescent bulbs. So are all our downlights going to be changing their ratings to a fluorescent bulb now?
Well, here's the good news, and this is kind of an interesting one. What you have to do is work with the manufacturer, and you have to tell the manufacturer, I want the sticker that says this is a 60 watt fixture. Even though you and I know it's literally the identical fixture that can handle 75 watts, they can put a sticker on it that says this is the maximum wattage you're allowed to install, and then it becomes a 60 watt fixture. And at that point, it only counts as 60 watts against you. So that's the short answer, is you get the sticker that says 60 watts.
Yeah, literally. And it's about capacity, is what they're saying. And, you know, if I'm a maintenance guy and I'm going around, I look and it says, oh, I can only put 60 watts in there, then I'm not going to put, hopefully, I'm not going to put any larger than a 60 watt lamp in there. And that's what they're trying to do.
I guess my question is, I get some clients in like commercial office buildings. They don't like when I put in a special fluorescent lamp that has your quad tubes, double tubes. They can't go find the bulbs down at the store.
Sure.
They call up me, they all mad and cussing me out because they can't find.
Even though you saved them hundreds of dollars on their lighting bill. But
they said they want to put in the screw-in fluorescent bulb. That's fine.
But in essence, unless your fixture has the sticker, it's going to be counted as an incandescent bulb, because the problem is, you know, you might put that screw-in Edison-based fixture in there, and then this client goes out of business or sells their building, and somebody else moves in, and they screw in these kind of bad ideas. Who am I cussing out here? I got to be careful. Where's the facility?
Yeah. Well, you could
we're
have
gonna do a little calculation
a sticker
in a
where
minute
it says
on this
like
room.
20 watts or something put on there, so all they can use is. Let's see if
But yeah, I hear what you're saying. I think in the end, though, if you're going to do that, you need to work with the manufacturer and get them to specify that this is a 30 watt fixture, and see if you can get that. Or true.
Rated for this for an incandescent or this for a.
That's not going to work, though. That's not going to work, because someone could screw in an incandescent and be the high wattage. Well, it is from the code standpoint. All right, track lighting. Here's a scenario: 5 track heads. That's wrong, because the correct way to do track lighting is what? 30 watts per foot, right? So again, just kind of trying to show you a little example that sort of shows how if you do it the wrong way, you get the wrong answer, and if you do it the right way, you get the right answer. That really makes a lot of sense, what I just said. But that's what happens. All right, so as long as your budget is greater than 1,650 watts, and you're at 1,650, you pass code. That's basically what it comes down to. Once again, CommCheck is your friend in this. The controls for lighting, we're done with the design, Brandon, check. The controls for lighting, ASHRAE and the other code are very big on saying, look, anytime you get above a certain size, a fairly small building, anything of 5,000 square feet or greater, we want to make sure that when that building is not occupied, that those lights are not on. That's the big thing, because nothing saves energy like turning stuff off. You can quote me on that if you want. So That'll be on my tombstone. Nothing saves energy. So, Brandon, how might I achieve this capability or satisfy the code on this?
You could have a time clock. You know, if you know that your office hours are 8 to 5, you know, it's going to automatically, you know, at 5 o'clock, it's going to switch those lights off. Maybe an occupancy sensor. I think depending on the type of building, you know, if there's nobody there, hey, we'll switch it off. One of the things that we like to use actually is tie it to your security system. Last person out, it's going to turn those off. You know, it says, hey, we're armed, nobody's in the building. You know, in addition to arming the building, let's go ahead and shut the lights off. So I think that's a pretty good approach. Obviously, there are, like everything else in the code, some exceptions. You know, certainly if you have 24-hour operations, it doesn't make a whole lot of sense. Patient care, or anything really when it deals with safety or security.
Okay. Any questions on that? So that's a big one. I mean, that's a big deal. But both codes basically have this provision. You've got to have the lights be off when no one's there. It's a great way to save energy. Now, in terms of the basics for controls from the ASHRAE standpoint in the other code, they want the control to be located conveniently, and they want the control to be located so that when you, in general, turn it on, you can see the result of what just happened. Right? So a way to think about it is if the light switch for the lights in this room is up here behind the wall and the door everybody uses is over there, then people have a tendency to leave the lights on if they're walking. I know we're in a daylit space, but people would have a tendency to leave the lights on when we don't need them. So they in general would like the light switch kind of to be as you walk in the door, and so you can see what happens when you turn it on. That kind of makes sense.
Where might you not want this to occur? Walmart?
I really like it. Actually, my favorite, I get really good discounts. I go into Target and Walmart, and I turn off all the lights, and I just help myself. And it's a...
So there is an exception for, you know, for like safety or security. So maybe you've got a big box retail. You do not want all of your customers to be able to come in and turn off the lights. That makes sense. Fair. Yeah, another great example. So if there's a safety or security concern, that is exempted.
They would like, if you're going to use like a circuit breaker to do this in that example, they want to make sure that the circuit breaker has an indicator that says, you know,
on or off.
Lights I can't see out in the main area, but I can tell if the lights are on or off by the circuit breaker. So that's another thing they want.
There needs to be a control for at least each room, one per room or space. So anything that's got ceiling height partitions, they're going to consider a room or a space. You have to have at least one control.
So ASHRAE, again, does this a little bit differently. They also say there's a rule for a certain size room where we don't want you to try to have everything on one light switch.
Yeah, so as the rooms get larger, they give you some guidance on how many controls to have. So if I've got a space that's 10,000 square feet or under, for every 2,500 square feet, I have to have at least one control. This is the minimum.
Yep, that's kind of one set of rules for spaces under 10,000.
Yeah, and then once I hit over 10,000, maybe in its arena or something like that, a large warehouse, I only need one control for each 10,000 square foot. Each 10,000 square feet.
Okay.
And then there's an override.
So here's an example of an 8,000 square foot building. How many controls does the 8,000 square foot space need?
Yell it out.
If you get it right, we get to go home. That's the best part.
4 is the answer. So I got 2,500. First 2,500 is 1. Second 2,500 is 2. Third 2,500 is 3. That's 7,500. We've gone above and beyond that, so it's 4.
Okay.
How about for the 12,000 square foot space? 2. Yeah, exactly.
Does everybody see why that is? It's just kind of a fluke, but it sort of says there's a different rule when you get above 10,000 square feet. And
they had to set the line somewhere, and it happens to be at 10,000 square feet.
Okay. So that's a little bit bizarre. The other thing is the code says, in addition to these control requirements, they said certain types of spaces, it makes a lot of sense to put either variable light levels, so multiple switches that can vary the light levels, or to put a sensing device that will automatically shut off the lights when the occupants leave. Okay? I cross this out because I get confused the way it's written. But essentially, the places that they would like you to do this are a classroom, a meeting room, or a break room. Okay? And then they, of course, say classrooms except K through 12. Yeah. But shop classes, I guess, laboratory class. So if you've got an adult education class, for example, then they would like a device in there that when you leave, the lights will automatically turn off, or at least something that allows you to have varying light levels in that space. So this is where we kick into this concept of the occupancy sensor and the vacancy sensor. Okay, I think I covered this yesterday. We didn't talk about this yet, did we? No. When you walk into a room that has an occupancy sensor, what's going to happen? The lights come on. And then when you leave and it detects that no one's there, after a certain amount of time, what will happen? Lights turn off. So you got automatic on and you got automatic off, right? So a vacancy sensor is different from an occupancy sensor. When you walk into a room with a vacancy sensor, what happens? Nothing. Nothing happens. Nothing happens. The lights, you have to manually turn on the lights. But when you leave, what does the vacancy sensor do? It senses that you're gone, and after a certain amount of time, it shuts off. So a vacancy sensor is kind of a manual on, automatic off. Which one do you think actually saves more energy? Does that make sense? I think a vacancy sensor is a really good idea for a room like this, or that has daylight in it, a room like a break room with windows, something that has where you might just be passing through. And if I'm just passing through and the occupancy sensor kicks on, that actually arguably wasted energy. If I'm just passing through and I can see to get through, I'm not trying to, operate small machinery or something, then I'm probably fine without it. So keep that in mind. Any questions on this? The way this was worded always confused me. So they say, you have to do this, except if your space has multiple light levels, and it has to be in all these rooms. And here's an example of a way you could do this. You don't have to do this, but you could either use a vacancy sensor or, where you control your lights. If you got a 3-lamp fixture, one switch turns on the middle bulb of all the fixtures. The other switch turns on all the outboard bulbs. And if you have them, so you can basically have 1/3 light level, 2/3 light level, or 100%. Does that make sense? Okay, that would work. We also like to try to encourage people in a room like this where you might be doing some display, like a conference room, where you might be projecting on a screen. Switch this fixture separately. Because a lot of people project, it seems like a lot of times in conference rooms you're projecting on something. Switch that one separately. Other big thing is the code says we won't necessarily count the wattage of these, but you have to have a separate switch.
Oh. So again, a lot of these fall outside of that sort of general task lighting. It tends to be, except for the one that says task lighting, I think it's talking about at a workspace. But, display accent lighting, hotel, motel, guest rooms, non-visual, demonstration lighting. So again, all these just need to be switched separately.
Okay. And the last thing here is that second to last thing is that tandem wiring. This is kind of an ancient dinosaur issue that had to do with back when you had a magnetic ballast. The wattage of the ballast used to really work against you. And so what they didn't want you to have is, here's a 3-lamp fixture with 2 magnetic ballasts. Here's another 3-lamp fixture with 2 magnetic ballasts. You had an extra ballast. So if they were close, they wanted you to connect the two. That's pretty much a thing of the past. I don't think you run into that very often. Exit signs. So the code never comes out and says you got to have an LED exit sign, but what do they say, Brandon?
You have to have an LED fixture. Yeah. Shall not exceed 5 watts per face. So essentially all you can use is going to be an LED fixture.
So you don't count the wattage of the exit sign in your budget, but it has to be really, really, efficient. So an LED is probably the only way to get there. All right, let's move outside.
So that's controls. Real quickly, Landon's probably is going to pass out your certificates as well as evaluations. please give us good, honest feedback. We're doing this course, but between now and the end of June, but anything we can do between now and then to improve it, we appreciate your feedback. So thank you.
Yeah. So we still have a few more things to talk about, but we're doing pretty good.
Yeah. So
the outside lighting, you got to do basically the same thing.
What's interesting, so we build our budget on this, but they even actually give you a little extra credit. So you start with your budget based upon some tables in ASHRAE, and then they're saying, hey, on top of that, you actually get an additional 5%. And there's sort of two tables that we're going to be looking at. One is called tradable surfaces, which in that table you can trade wattages between the various surfaces that we're talking about, and then non-tradable surfaces, which you cannot trade.
Non-tradable, kind of a use it or lose it if it's optional, if it's there. So again, a very similar concept. I've got a 1,000 square foot parking lot and driveway. I go to a chart and it says 0.15 watts per square foot, and you come up with your exterior lighting budget. I've got some doorways, I've got some entryways, et cetera, and you build your budget, and then you're allowed to use that wattage however you want to in those spaces. So you could say, well, I think I'm going to underlight the parking lot but really light up the walkway. That's okay. You can use the wattage as long as you don't exceed your budget. That's all for tradable surfaces. The non-tradable are what we call the use it or lose it places. Okay, so this is where if you're going to, for example, light up your building facade, you're allowed 0.2 watts per square foot per exterior facade. If you're not going to light up your building, you can't borrow that wattage and use it out in the parking lot. Bummer. Okay? If you have an ATM outside, you get an extra, how much? How much do you get? 270 watts. Okay? But if you don't have an ATM, you can't like say, well, I didn't really want to use it over here at the ATM. I think I'll move it over there. So you can't trade it out. Yeah. Yeah. No, that's so the question has to do with light pollution. And it's kind of a different issue. This is related for sure, but light pollution tends to be less tied to the wattage of the fixture and more tied to the type of fixture and how it's oriented.
It's where it's going. So light pollution, if you think about it, is light trespassing off your site, either on the boundary or up to the sky. And so what they're trying to make sure is that you're not letting any light actually trespass off your site, getting into your neighbor's yard essentially, and don't waste that energy trying to light the night sky. So using a full cutoff fixture will fix all that, but it does not have really anything to do with the wattage you're allowed.
Yeah. I mean, it's a good question. So yeah, the wattage you're allowed is kind of set by the energy code, and it doesn't say how those fixtures are configured or anything. The Dark Skies Initiative is a program that looks at, it encourages it, like what Brandon said, to basically have down lighting, or what they call cutoff fixtures, which is like a can light. A can light has the bulb tucked up inside of it. You see the light coming out of the fixture, but you don't see the bulb. So that would typically be what you'd want to see from the light pollution standpoint, those kind of things. Is anybody here, a couple folks here have done LEED projects, right? If you've done a LEED project, then what they want you to do is essentially, if you want to get this credit for the light pollution credit, then what you're trying to do is you actually have to use 80% of the budget. So you have to come in with a lighting design that is less than what ASHRAE allows you, and your fixtures have to all be cutoff fixtures, in essence. That's the short, and no light spillage off your property. So
what I thought you were going to ask, we get this question a lot, is what about safety? If we're driving this stuff down, is it going to be safe? And Mike, talk about maybe the Centennial Park example. I think that's a really good one.
Well, the interesting thing, some people incorrectly, in my opinion, they associate safety lighting, that the safer it is, the brighter it is. And that's actually not true. What you really want is uniformity of light levels. In other words, if you've got fixtures that are, like the worst ones, they look pretty, but the worst ones are those globe type fixtures, there's a big round ball, and and they're so bright that they make glare. And so they actually, they also pollute the sky. They put light straight up, but they make a lot of glare, and it means that you've got dark spots and bright spots, and that's actually affects safety. The uniformity of light that's done well is consistent, where your foot candle levels don't vary that much. Your eye can basically take in everything. That's the safer lighting. And we were working on one of the early lead projects I think we were doing was the Georgia Tech Klaus building, this big 400,000 square foot building or something. And we were telling the design team this, and they were kind of a little skeptical, so we asked them to go. We sent them down to Centennial Park at night. So they're walking around with their light meters, and they were amazed that you could see really, really well and really safely. And in some cases, it was less than maybe like 0.8 foot candles or something. So it really is about consistency. That's what matters the most. I'm not a lighting designer, but I think that's a safe statement. Okay, so we're done with the budget for exterior. The design for exterior is basically, the fixture wattage, but there's a couple additional rules that apply. Number one being, anything 100 watts or less, you just count it as what it is, and it counts against your budget. But anything over 100 watts, the code would like that fixture to be very efficient. And usually parking lot lighting, what type of lights, what technology of lights do we see in a lot of outdoor parking lot lighting? Was it metal halide? Maybe some high pressure sodium, which is not the best quality of light, but very efficient. So the HID stuff, the high intensity discharge. So these are examples of lights that will all blow this 60 lumens per watt out of the water. So I'll tell you what won't pass that, though, would be those old-timey mercury vapor lamps, which I think are mostly a thing of the past. Probably, they don't make new ones, at least. So you're looking at the more efficient outside lighting for the high wattage fixtures. Once again, there's always some exceptions. You can put a couple 150-watt halogen bulbs if they're in a motion sensor fixture. Okay, so that's only going to turn on when something is detected. But in general, the high wattage fixtures outside, they really want to make sure that they're very efficient. Is that okay? Everybody good with that? Okay. And again, any of these other exceptions would apply as well. So if you're going to light your public monument, you can go nuts. Okay, some exemptions.
Again, a lot of other exemptions. You have to have, they have to be separately controlled. The same thing as we were talking about on the interior lighting. Even though these are outside your budget, there's a lot of opportunities for savings. Ball fields. How many people have seen ball fields where they're just lighting it up all night? I mean, that's absolutely ridiculous. So it's a good opportunity. So just because it's not within your budget, please, please, please think about this and try to save some energy, save money.
See, I think that what we should have is some sort of a code requirement that says ball field lights have to have the meter for the ball field lights right there next to the switch, and have to take a picture of it every minute and send it to the comptroller or whoever pays all the bills. So that, in other words, when those lights are on, what's the meter doing? So I think people just leave them on because they don't associate the cost of that. And I think the meter should spin off and it should count up in dollars. That's my process, I think. If people saw that, wow, it cost me, $15 for 5 minutes of operation here, I might be thinking about what I'm doing and leaving those lights on. It's just clicking like crazy. People are often amazed at the economics of lighting. The economics of lighting, you do not need fancy tools. Does anybody here know how to use an Excel spreadsheet or a calculator? You can do it. You could do, and I mean, we actually teach that in some energy assessment classes that we do, that it's like literally just with a calculator you can estimate the savings really quickly, or with a spreadsheet you can estimate the savings really quickly. How many of these light fixtures do you see in this space right here? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 4. 36 fixtures. What do you think the wattage is of these bulbs? 150? All right, calculator? Oh, dang. What's 36 times 150? So when these lights, this one, and then by the way, there's more of these out in the hallway, I should mention. But when these are on, That's 36
5,400.
fixtures times 150 watts each. That's 5.4 kW. 5.4 kW, 5,400 watts. Okay? And if those are running, if these are left on for 1 hour, a single hour, that's 5.4 times 1, that's 5.4 kWh, 5.4 kilowatt hours. Okay? And if it costs me, I mean, you know, if I leave these on for you can do some math. You can start going, well, these are on average, you know, 8 hours a day times 4 days a week or whatever. You can figure this out, and you'll start to see the economics. A good rule of thumb, you know, you can just say about 10 cents a kilowatt hour. That's probably a little bit high for commercial, but it's probably low for residential. So about 10 cents a kilowatt hour. So it literally costs us, you know, 50 cents an hour to leave these lights on, just this one room right here. And you start going around all the other light fixtures, and you start saying, well, that really kind of adds up. You start looking at how many hours in a day. You know who really stands to benefit from this is retail and fast food. Because fast food uses fluorescence in the kitchen, but they always use incandescent in the dining area. Have you noticed that? And they probably fail code, by the way, in many cases. I've always wondered how they pass code. And people say, oh, well, we dim them a lot. But most of these are not dimmed. I haven't been dimming them. I'm afraid to. I'm going to get in trouble. So I think that the opportunities on lighting is pretty consistent, is pretty significant. So in the end, like Brandon said, just because it's not covered under your budget doesn't mean you can't save a lot of energy. Most of these are process lighting. Okay. We're one more tick, and then we're on the last one, which is controls.
One quick question.
Okay.
Would it be more efficient to have more windows, which we already determined is not efficient, or more lights?
Oh, that's a
Okay,
great question.
yeah,
What do you think? The question is, what's the best answer? To use a lot of windows or use a lot of lights? What do you think is more efficient? Yeah, well, it depends, right? It's a good question. But one way to figure that out is the next section we're going to talk about, which is energy modeling, can answer that question for you. But in short, a good design is one that puts a lot of windows strategically. Strategically, what facades do I want to put a lot of windows on here in the southeast? North-facing and south, not east, north and south. South with a modest overhang is going to do a great job of shading those windows when you want to shade it. So it's north because I think we have a light shelf picture in here. Do you remember where it is? Help me.
I think it's at the very beginning of this section, actually.
Is it? I'll find it.
Yeah, because it's the office.
So north windows and south window at the beginning of this section, really?
Yeah.
Oh yeah.
Look at
143.
page.
Yeah, you're right.
Yeah, 143.
Okay. So you put windows on the north, you get a lot of indirect light. That's fantastic. It's great natural daylight and very little solar gain. Beautiful. The problem with north-facing windows is you can only, if you will, daylight a space in usually about, I'm going to just wave my hands here, but let's say about 15 feet. You get about 15 feet of daylight, really good daylight. And then after that, the further you go from the window, you get some light, but you're not getting enough foot candles typically. Okay? With south-facing windows, so let's say that's facing north right there. I'm not saying it is, but let's pretend it is. Those windows are fine. But with south-facing windows, if you put a light shelf and shading devices, you can actually bounce the light off the top of the light shelf and off the top of the ceiling, and you can kick natural light 30 or 40 feet deep into a space. So the answer is to use windows intelligently. And if you come and visit our building, we'll give you the tour and show you all this. But you can actually essentially optimize the design so that you get the windows for light, and you get the light where you want it, and you put automatic lighting controls. This is a very common scene in Brandon's office, which is all the lights are turned off.
Yeah. And so, for instance, in here, wouldn't it, we've got these lights. Wouldn't it be great if we had a daylight sensor? I mean, I think probably at this point we don't really need the lights on. This morning when it was cloudy, it was rainy, of course we needed them on, but this would be a perfect example of where we've got these windows. we can utilize that natural daylight and not expend the energy. Let's use the free energy of the sun to light our space.
So does that kind of answer your question, Linda? You can, and light shelves, you can do some pretty cool things with light shelves, and you can really optimize the design to do great things.
There's no simple answer for that, but I think you have to, if you're starting to think about it, you've won half the battle. You just need to be intelligent about how you're designing these things.
Sorry, I was trying to figure out where we are. Okay, the last thing we want to talk about is outside lights, controls. And the rule here is very simple. When should exterior lights be turned off? Thank you very much for saying during the daytime. That was excellent. Oh, there's one of those globe fixtures outside. I see it out there. You have to open the blinds, Landon, so people can give them a view. By the way, give people a view. There, I see it. No, I still can't see it. You have to unscrew the blinds. So. All right. So we want to turn lights off during the daytime. And the code says you can do that as simply as you want to with a photocell, and that's probably the cheapest option. Or you can use a time clock, or you can use a time clock and a photocell. And the time clock has to have some backup in case the power goes out, so that's an important thing. But and it also is supposed to adjust for daylight saving time, so it's kind of electronic time clock. But the idea of a time clock and a photocell has to do with this concept of curfew lighting. Has anybody heard of that before? Okay, so what time is it going to get dark tonight? 8 o'clock, something like that? So, at 8 o'clock, the lights come on, and the building that we're in, let's say, it has a night shift or it's a retail establishment. It goes and, about 10 o'clock they close down. About 10:30 the staff is out of there. So we keep a level of light in the parking lot that is pretty good foot candles. But then at, let's say, 11 o'clock or midnight, we go into curfew mode, which means what? What are we going to do with the lights? We're going to turn off some of them or dim them all down, right? And so in other words, we can squeeze out extra savings when probably the building's not occupied. We still have some security lighting in there, but we're going to take the light levels down or shut off some fixtures. So that's, again, a way with controls to kind of, really juice out some extra savings. Okay. We have now covered interior and exterior budget, design, and controls. Does anybody have any questions on lighting?